Wood Johnson Foundation. Americans report these events caused serious health problems, severe financial woes, and property damage. I know just yesterday I was talking to a Michigander who said she is still getting her house in order from floods she experienced last year. No state in our nation is untouched by the damaging physical and emotional impacts of climate change. As the hottest part of the year now gets underway, families across the country are bracing themselves for another season of devastating hurricanes, storms, floods, fires, and heat waves, all while we're just trying to enjoy the 4th of July. So it is timely that on the brink of this summer season, we are holding this hearing to examine the tools the government has to properly track our greenhouse gas emissions and where our data is falling short. Greenhouse gases act like a blanket. The gases trap heat in the atmosphere. These gases include carbon dioxide, methane, nitrous oxide, and other fluorinated gases, and they're a driving force of climate change. Since the start of the Industrial Revolution, human activities have vastly increased the volume of greenhouse gases emitted into the atmosphere. Reducing greenhouse gas emissions is essential to mitigating the effects of climate change. I hope that that is no longer a controversial statement in Congress or one that requires further explanation. It is the year 2022, and we have been talking about this since mid-last century. Yet we seem to be arguing about whether or not we should do anything. And so I can only hope that this nation's leaders are able to come together soon to enact real policy to reduce emissions and address the threats that are already at our door, because it is not too late for us to respond. And in fact, this can be an opportunity for us. I come from an industrial state. I come from the heart of automotive land in Michigan, and our industry leaders are also environmental leaders, because our industry leaders are our manufacturers. They are the people who work in manufacturing facilities who love to go up north. They love to access our Great Lakes. They like a regular temperature over the summer, and they certainly don't want to experience flooding in their home and incurring the costs. So when we don't enact real policy, we need the tools to track progress and guide evidence-based decision-making. That's what this science committee is all about. We will want the most accurate tools to ensure that we are reaching our goals, but also, importantly, ensure that we are able to hold other nations to accountable measurements. To be global leaders, we need accurate and consistent greenhouse gas data, and that is where our federal science agencies come in. Many of our agencies, including those represented by the experts before us today, are engaged in tremendous research and development work to improve our measurements of greenhouse gas emissions. This work spans the whole range of greenhouse gas measurement activities, from fundamental measurement science and technology development to operation of science-based airborne and ground-based sensors and observation platforms to maintaining greenhouse gas emissions inventories. These agencies do not do this work in a vacuum. Each of these agencies represented here today cooperate on vital interagency work to improve greenhouse gas measurement, both on individual projects and as part of an interagency working group. Hooray! Government coming together for a productive outcome for the public good. This cooperation is essential to the success of our greenhouse gas measurements. So much can be accomplished when our federal science agencies leverage their respective expertise in support of a common goal. I am looking forward to this hearing, and I'm looking forward to hearing more about the work that our witnesses are here today to discuss with us to support and improve the programs underway. So thank you again for joining us. The chair is now going to recognize Ranking Member Feenstra for an opening statement.
Well, thank you, Chairwoman Stevens, and thank you for your passion. And thank you to our witnesses for your participation today. I'm very grateful to have you here and to hear from you. We're here to discuss the measurement and monitoring of greenhouse gases, which can improve the tools we have available to reduce and capture emissions. Importantly, we're not just going to discuss emissions, but also sinks. and the processes that remove greenhouse gases from our atmosphere. One example is the land use and forestry sector, which offset total U.S. greenhouse gas emissions by 13% in 2020. This is an important contribution to emission reductions, and federal R&D can help us make even this go further. For example, we now know the potential to improve carbon sequestration in cropland through conservation, tillage, and other practices. Without accurate data, however, it's difficult to make significant progress in any greenhouse gas reduction efforts. So federal science agencies are working with academia and industry to improve the monitoring, measuring, and verifying of the sources and sinks of greenhouse gas emissions. Better monitoring and measurement technologies give us the ability to implement more efficient and cost-effective practices to reduce greenhouse gases and its concentrations. I'm encouraged by the work being done today, and I see great potential. For instance, the National Institute for Standards and Technology, Nist, is using an innovative approach through its greenhouse gas measurement program. While most cities estimate greenhouse gas emissions indirectly through economic data, such as the number of miles that vehicles drive within the city, Nist has developed atmospheric observational tools to measure emissions directly. By combining the indirect and direct observations, scientists can make better estimates for emissions and provide more useful information to its stakeholders. Nist also operates an urban greenhouse gas measurement test bed system, which develops and evaluates the performance of emission measurement capabilities in Indianapolis, the Los Angeles Air Basin, and the Northeast Corridor. In order to help measure, monitor, and report greenhouse gas emissions in an accurate, standardized, and transparent manner, Nist has also initiated a documentary standard effort. This work will help develop best practices that improve industry's ability to use measurement tools and quantification methods to reduce greenhouse gases in the environment. Eventually, the hope is that we will lead to the development of technical standards to improve the data quality of greenhouse gas emission reports. NIST also works with other federal agencies through greenhouse gas monitoring and measurement interagency working groups to coordinate existing efforts. The coordination is so critical. We can't afford to have agencies duplicating work or worse, providing conflicting information. So I'd like to emphasize to our witnesses today how important it is that we continue to coordinate research activities moving forward to maximize our resources. In addition to learning more about the work being done to better understand life cycle greenhouse gas emissions, I hope to learn more today about where measurement and data challenges exist and where research gaps remain. I look forward to hearing your perspectives on that, and I want to thank our witnesses again. Madam Chair, thank you for putting this hearing on, and I yield back.
And at this time, I would like to introduce our witnesses. Our first witness is Dr. Eric Lin. Dr. Lin is the director of NIST Material Measurement Laboratory, MML. MML has more than 900 staff members and visiting scientists and serves as the nation's reference laboratory for measurements in the chemical, biological, and material sciences. Another best-kept secret at NIST. Dr. Lin has also served as the acting associate director for laboratory programs at NIST, during which time he provided direction and operational guidance for all of NIST's scientific and technical laboratories. Our next witness is Dr. Ariel Stein. Dr. Stein is the director of NOAA's Air Resources Laboratory and acting director of NOAA's Global Monitoring Laboratory. He has extensive expertise and experience working with atmospheric transport, dispersion, and photochemical models. Prior to his current role, Dr. Stein served as a supervisory physical scientist at the Air Resources Lab. Our third witness is Dr. Karen St. Germain. Dr. St. Germain is the division director of the Earth Science Division in NASA's Science Mission Directorate. In this role, she provides executive leadership, strategic direction, and overall management for the entire agency's Earth science portfolio. Prior to coming to NASA, she served as the Deputy Assistant Administrator Systems for NOAA's Satellite and Information Service. She has also previously served in positions at the Department of Defense. Our final witness is Dr. Bryan Hubbell. Dr. Hubbell is the National Program Director for the Air, Climate, and Energy Research Program in EPA's Office of Research and Development, ORD. Dr. Hubbell has worked for EPA for 24 years as an expert on the health and environmental impacts of air pollution. He led the EPA project team that developed the Environmental Benefits Mapping and Analysis Program, which is used around the world to estimate the benefits of clean air. As our witnesses should know, you'll have 5 minutes for your spoken testimony. Your written testimony will be included in the record for the hearing. And when you've all completed your spoken testimony, we will begin with questions, and each member will have 5 minutes to question the panel. We're going to start with Dr. Lynn.
Okay, Chairwoman Stevens, Chairwoman Sherrill, Ranking Members Feenstra and Bice, and members of the subcommittees. I'm Dr. Eric Lynn, Director of the Material Measurement Laboratory at the Department of Commerce's National Institute of Standards and Technology, Nist. Thank you for the opportunity to appear before you today to discuss Nist's role in greenhouse gas measurements. The Nist laboratory programs work at the frontiers of measurement science to ensure that the U.S. system of measurements is firmly grounded in sound scientific and technical principles. For this hearing, the Nist Greenhouse Gas Measurements Program helps businesses and governments at all levels measure, monitor, authenticate, and report greenhouse gas emissions in an accurate, transparent, and standardized manner. This measurement program will help cities demonstrate that they are contributing to the administration's national greenhouse gas emissions reduction targets for the next 20 to 30 years. Nist provides a system of observation networks for measuring greenhouse gases at the city level and even down to the street and block. Our work complements that of our partner agencies with their expertise in quantifying greenhouse gases on larger scales by regions and continents. To demonstrate the feasibility and validity of Nist's granular approach, Nist established the Urban Greenhouse Gas Measurements Testbed System. This so-called Urban Dome project provides the measurements and accuracy that businesses and governments need for mitigation actions and science-based policy decisions. The Urban Dome project can measure and map emissions at any level needed, down to an individual building and over a range of time resolutions, from annual variations to seasons, weeks, days, and hours. Nist operates measurement test beds in Indianapolis, the Los Angeles Air Basin, and the Washington, D.C. Baltimore region, with plans to extend through the Northeast Corridor to Boston. These test beds encompass a range of conditions that represent the span of U.S. urban areas. The Nist Urban Dome project is a partnership with members of government, business, academic, and non-governmental organizations. The Urban Dome project develops and provides mature measurements-based scientific tools, methods, and data to better estimate greenhouse gas emissions. These validated tools will enable the identification of the most economically viable emission reduction opportunities in urban areas. Application of these tools before and after the deployment of energy efficiency or alternative energy solutions can authenticate their effectiveness. This toolkit will soon include international documentary standards to which Nist provides technical expertise that will improve data quality in national greenhouse gas emission reports. High-quality data will help the community judge progress toward national emissions reduction targets. Nist works closely with our federal partners in the Greenhouse Gas Monitoring and Measurement Interagency Working Group. Coordination through this group is essential to continue to maximize the impact of agency resources, enhance the nation's ability to measure, quantify, and monitor greenhouse gas emissions and removals, and accelerate the transition of relevant research to operational use. Interagency and additional collaborations can enhance our understanding of greenhouse gas emissions by linking surface emission measurements to satellite and airborne observations for even more robust domestic measurement and monitoring capabilities. Modeling fossil fuel and biogenic emissions and uptake to better understand the effects of vegetation, wetlands, and similar urban features on emissions measurements. Developing measurements and models to relate atmospheric greenhouse gas concentrations to emissions. For more than a century, Nist has conducted measurement science that is impartial, accurate, and consistent, so that decisions in the business and policy realms are made on sound scientific footing. This helps to provide the measurements and data that the US and other nations need as they monitor and choose ways to reduce greenhouse gas emissions. We greatly appreciate the members of these committees and others in Congress for their support of federal research and services that support greenhouse gas mitigation efforts. And I'll be pleased to answer any questions that you have. Thank you.
And now we'll move to Dr. Stein.
Chairs and ranking members and members of the subcommittee, thank you for the opportunity to testify today regarding federal programs focused on monitoring, measuring, and verifying sources and sinks of greenhouse gases. NOAA's mission is to understand and predict changes in climate, weather, the oceans, and coast. To achieve this, we must continuously monitor and detect changes as they occur. The primary focus of my work is to monitor and detect changes in the atmosphere that impact climate. This is something NOAA has a long history of doing. With CO2 measurement dating back to 1958, NOAA's Monologue Observatory in Hawaii is the global benchmark location for monitoring atmospheric composition and was key in determining the connection between rising atmospheric CO2 levels and climate change. Building off these historic accomplishments, NOAA's long-term continuous atmospheric observations serve as a baseline and record which can be used to monitor natural and anthropogenic emissions on greenhouse gases, as well as their uptake by natural, land, and ocean-based processes, and the effectiveness of efforts to reduce climate change through greenhouse gas mitigation. The Monologue Observatory continues today as a cornerstone of NOAA's global greenhouse gas reference network. This network has grown to a global scale with more than 70 sites around the world, measuring over 60 gases. This high-quality data serve as a backbone of NOAA's climate mission by providing vital environmental intelligence for monitoring the steadily changing composition of Earth's atmosphere and understanding global weather and climate. NOAA uses this foundational climate information to develop products and tools to help inform decision-making. NOAA's greenhouse gas data feed models to predict long-term changes in climate that have the potential to impact long-term planning needed for industries like shipping, fishing, forest management, agriculture, construction, finance, and water resources. For instance, NOAA has developed a system based on measurements and models to detect long-term changes in sources and sinks at the global, national, and regional levels. NOAA is also working to better understand changes in greenhouse gases emissions and air quality in our nation's cities in partnership with other agencies. In particular, NOAA conducted research on how greenhouse gas emissions coming from urban environments may not have changed much during the lockdown period of COVID-19, while significant changes were simultaneously observed in air quality. NOAA has also conducted research with the oil and gas industry to pinpoint fugitive emissions to realize efficiencies while ensuring the safety of these sites and preventing the loss of valuable fuel that could be captured and sold. These are just a few examples of NOAA's boots-on-the-ground approach to providing climate services. Just as with our other climate services, by connecting with communities and leverage our greenhouse gas network, NOAA helps local decision makers strengthen our resilience and adaptation to climate change, which will help protect lives, lifestyles, and livelihoods. NOAA's work on understanding sources and changing in greenhouse gas emissions and sinks requires cooperations with numerous agencies. Each agency represented here today brings to the table core capabilities that complement each other and will help us advance this field. NOAA is also looking towards expanding the greenhouse observational network by using new technologies to allow the detection of greenhouse gases at higher temporal and spatial resolutions. For example, NOAA is working with the airline industry to help expand our agency observing network by putting instruments on commercial aircraft to acquire data as planes ascend and descend. Much like how the National Weather Service already partners with commercial airlines to gather meteorological data, this new capability has the potential to provide orders of magnitude more observation of the atmosphere in climate-sensitive regions like the Arctic, and the tropics, as well as high-emitting regions surrounding many metropolitan airports. This data may allow NOAA to detect greenhouse gases changes at finer resolutions, which will improve the climate information available to decision makers at the regional and local scales. Thank you, and I look forward for your questions.
Great, and now we'll hear from Dr. St. Germain.
Chairwoman Stevens, Ranking Member Feenstra, Chairwoman Sherrill, and Ranking Member Bice, and members of the subcommittee and committee. I'm Dr. Karen St. Germain, Director of NASA's Earth Science Division, and I'm very pleased to appear before you to share NASA's role in measuring, monitoring, and understanding the role of greenhouse gases in our warming climate. NASA's mission is to provide the observations and foundational science that underpin our understanding of the Earth as a system. We're working to bring cutting-edge space-based and airborne instruments and observations, advanced modeling, new technologies, and analytic techniques to deliver world-class scientific understanding of the Earth system. In doing so, we support the broad range of efforts across the agencies you see here and many others in the federal government and beyond. We're committed to open science and collaborating with our colleagues here to offer policymakers and Americans actionable information in support of their efforts to mitigate greenhouse gases and respond to the wide range of impacts of the climate change. We're moving out today to build the Earth System Observatory that will consist of 5 major missions, augmented by several competed missions. The Earth System Observatory will give us an even better overall understanding of the Earth system and the interplay between greenhouse gases and the carbon and water cycles. Today, our instruments that measure greenhouse gases include OCO2, the Orbiting Carbon Observatory, and OCO3, its sibling on the International Space Station. NASA Airborne campaigns obtain high-resolution temporal and spatial measurements of complex local processes, which give us an even clearer understanding of what our global satellite observations are telling us. For example, the Moose campaign in Michigan lets us better understand why we're seeing elevated ozone levels at the Michigan-Ontario border region, while other campaigns have been critical in documenting methane supersources. NASA continues to advance technology for new space-based and airborne measurement capabilities, and in developing these tools, NASA strives to make these technologies reliable, affordable, and deployable. And when there's opportunity, we transition these technologies to the private sector, as is the case with NASA's Jet Propulsion Laboratory partnership with Carbon Mapper, Inc. Our technology efforts will enable better measurements of carbon dioxide and methane fluxes and trends in varying conditions. The Carbon Monitoring System, or CMS, has allowed us to combine observations of greenhouse gases in the atmosphere with other types of measurements to give us a better understanding of the Earth system processes, such as the carbon cycle. CMS projects have provided insight into the role of forests and cropland in greenhouse gas fluxes, including whether certain lands under agricultural use are carbon sinks, sources, or both under varying conditions. For example, Midwestern cornfields are carbon sinks during most years, while during years of water stress, they release carbon, even as Oklahoma winter wheat might show no notable change under similar environmental conditions. CMS-funded scientists built a new series of maps detailing the global geography of methane emissions from coal, oil, gas, and other sources. Using publicly available data reported, the research team plotted fuel exploitation emissions that arise before the fuels are ever consumed. NASA's greenhouse gas research and its applications depend also on partners and their assets, from NOAA's SUMI NPP to the European TROPOMI and the Japanese GOSAT, and we work with partners at NOAA, EPA, and Nist to assimilate many sources of data to help understand the nature of greenhouse gas emissions. NASA is working with other agencies through the new Greenhouse Gas Monitoring and Measurement Interagency Working Group to maximize the impact of agency resources, enhance the nation's ability to measure and monitor emissions and removals, and accelerate the transition of relevant research capabilities to operational use. And we at NASA are building on these efforts toward an Earth Information Center with an initial focus on prototyping capabilities for greenhouse gas monitoring and information that will integrate the data from these variety of sources with the goal of making that data more accessible and usable to federal, state, local, and tribal governments, as well as researchers, the public, and other users. NASA's $2.4 billion request for Earth science in the 23 President's budget will allow us to continue to make this strong progress in observing and understanding the Earth as a system, including greenhouse gas emissions, and just as importantly, understand how the widely varying impacts of the changing climate are affecting our communities from the coast to the heartland. NASA stands ready to work with our federal, state, tribal, local, and commercial partners to address the challenges posed by greenhouse gases and their effects. And I want to thank this committee and Congress for its support of Earth science and the entire federal government's efforts to tackle the challenges we're discussing today. And I welcome your questions.
Fabulous. And with that, we'll hear from Dr. Hubbell.
Good morning, Chairwoman Stevens and Cheryl, and Ranking Members Feenstra and Bice. My name is Dr. Bryan Hubbell. I'm the National Program Director for the Air, Climate, and Energy Research Program in US EPA's Office of Research and Development, known as ORD. I have 24 years of experience at EPA applying, conducting, and leading research on the health and environmental effects of air pollution and climate change. A key element of the ACE program is development and application of methods for measuring air pollutants and greenhouse gases. I appreciate the opportunity to talk with you today about ORD's important work to advance greenhouse gas measurement. Accurately quantifying greenhouse gas emissions is an important part of EPA's work. Greenhouse gas data are used in a variety of ways to inform decisions that help protect the health of our nation. Accurate and comprehensive source-based greenhouse gas emissions data provide the foundation of EPA's emission reduction programs and allow EPA and others, including Congress, to evaluate the effectiveness of those programs. Emissions data are also used by states and communities to understand their emissions and develop mitigation strategies for their particular needs. EPA's Office of Air and Radiation also uses source-based emission measurements and modeling for the U.S. greenhouse gas inventory. While ORD does not make policy decisions, we work hard to ensure that EPA program offices, other federal agencies, states, tribes, and communities have the highest possible data quality so they can make well-informed decisions with confidence. ORD's research is currently focused on source-based measurements of methane and other non-CO2 gases. This work is critical to informing both national and international greenhouse gas inventories, and it supports regulatory and voluntary emissions reduction programs. It also contributes to EPA's broader efforts to close the gap between source-based bottom-up inventories and top-down emission estimates. Our work in this area includes exploring ways to more accurately quantify methane emissions from oil and gas operations, improving mobile ground-based remote sensing technologies to measure methane concentrations at facility fence lines, and evaluating methane emissions from municipal solid waste landfills. In addition to this in-house research, ORD is also developing a request for applications through our research grant program to study methane emissions from landfills. We're planning to award $1 million in research grants under this request, which we anticipate releasing by the end of the year. While methane emissions from landfills and oil and gas facilities is a focus, our researchers are also looking at other greenhouse gas emission sources. For example, our research has significantly improved the understanding of greenhouse gas emissions from freshwater reservoirs, lakes, rivers, and other water bodies, which can be sources of methane, CO2, and nitrous oxide. Accurate measurements of these emissions are crucial to understanding the big picture of greenhouse gas emissions. New techniques developed by ORD researchers have already improved national and international greenhouse gas methodologies and inventories. And finally, we plan to evaluate how aquatic systems such as watersheds and wetlands can remove and store CO2 from the atmosphere. And we plan to research the role of blue carbon and how protecting coastal estuaries can benefit local communities while also reducing atmospheric CO2. Monitoring and measuring all sources and sinks of greenhouse gases requires the combined expertise of multiple federal agencies. EPA partners and coordinates with Noaa, Nist, NASA, DOE, and USDA at multiple levels to ensure we're using the best available data and measurement technologies and practices. This includes engagement through the U.S. Global Change Research Program and the Greenhouse Gas Monitoring and Measurement Interagency Working Group, and also on other research efforts. For example, ORD is collaborating with Nist, Noaa, the California Air Resources Board, and others to combine airborne, satellite, and ground-based measurements for landfill greenhouse gas emissions assessments. While EPA and other federal agencies have made great strides in greenhouse gas measurement, there are gaps in knowledge that we are working to address. This work includes resolving uncertainties in various airborne and satellite systems, establishing approaches that capture information about source locations and operational status, and identifying locations and events that can account for disproportionate amounts of greenhouse gas emissions. Even though my office does not directly make decisions regarding greenhouse gases, I am proud of the research we do that helps ensure that our EPA program partners, Other federal agencies, states, tribes, and communities have the data and information they need to make decisions to protect health and the environment. We look forward to continuing this research and to addressing key research needs in the future. Thank you again for the opportunity to appear before you today, and I'm happy to take any questions.
Well, thank you so much. And at this point, we're going to begin our first round of questions, and the chair's going to recognize herself for 5 minutes. So you all have spoken today about the fantastic work your agencies are doing and the interagency partnerships that are going to enable the success of much of the work at hand. Given all this collaboration, I wanted to dive a little deeper on the idea of integrated greenhouse gas observing systems. So what is the ultimate vision of an integrated greenhouse gas observing system, and what do we need to do to achieve such a system? And any one of you can start with that. Dr. St. Germain?
Certainly, thank you for the question. So, and I think all of the members of the panel may have something to contribute to this one.
Yeah.
I think it's really about doing the data assimilation. There are two elements, right? Bringing together the data and the models that we have, and the strengths of those from each of the agencies, but then also creating the interface that makes that easy to access. So, unleashing the power of that science by making it easy to access and understand by users at all levels to inform the decisions they have before them.
Yeah. Dr. Stein?
An integrated system will require going from global measurements and models all the way to the local realm. I would envision the idea of using satellite in situ tower, airborne platforms, along with the integration of models together. We also need vertical profiles of the atmosphere in order to understand the three-dimensionality of that, and going again from the global to the local, and also taking into account the sectors that we are going to study. Each sector is going to require a different solution. The stacks or industrial sectors do not have the same, are not looking for the same solutions as the urban areas. The forest problem or the uptake from forests requires a different set of tools. So all of that integral way of responding to this problem is key for tackling.
Yeah, and Dr. Lin, as we answer this question, just for the folks watching back at home, and given the division of Nist that you oversee, could you just give some examples of the units of measurement that we're talking about?
Well, probably the most important one is the concentration level. So of all the greenhouse gases, you need a concentration, so you need a composition measurement of the quantity of any gas within a given environment. That would be one. Another one would be basically all the quantities that are used to connect to those concentration levels. So those would be like spectroscopic measurements, where you need to know wavelengths and those type of units. But I would say concentration is probably the most important.
And those are global measurements? It's a universal unit of measurement?
Yes.
Not subject to the pain of the imperial system?
No, it's part of the system, international system of measurements, the SI system. The relevant one here is really the mole and the gram. So it's a measure of quantities. When we say concentration, it's a quantity per unit volume, which is related to mass. So these are all very universal and tied to the SI system. And we work very closely with our partners to take these fundamentals of something as straightforward as concentration and mass, and we have to connect it to concentration and reference materials that are done in partnership with Noaa as the official reference material primary laboratory for the international system.
And so, Dr. Hubbell, how does this system enable us to meet the goal to reduce greenhouse gas administrations? This is the integrated greenhouse gas observing system.
Right, so I just want to point out that in addition to these these kind of global measurements, it's really also important to get very local to be able to inform
we're seeing with the
mitigation.
more-
So the ground-based measurements that we typically are engaged with are looking at things like emission rates and looking at emissions coming from specific parts of the production process. So it's really important to, as we're thinking about global measurements of concentrations, to also remember that we need to have good understanding of emissions from individual sources and parts of sources so that we can create mitigation strategies. And that's a critical part as we're moving forward with thinking about these integrated systems.
Yeah, great. Well, and I know Dr. St. Germain mentioned that in her testimony, and we're very proud in Michigan of our bordered relationship with Canada and the great work that we do. And this is another phenomenal example. So I'm just slightly over time. I'm going to yield back. I'm going to recognize my hardworking colleague, Mr. Feenstra, for 5 minutes of questions. Thank you.
Thank you so much, Chairwoman, and I want to thank each of you for your testimony. It was very impressive and good information. Dr. Lynn, as you know very well, NIST's expertise lies in standards, and Nist has initiated the development of technical standards to help support accurate greenhouse gas emission measurements. Could you provide us with an update where Nist is in the process and how Nist is working with the industry to develop these standards?
Thank you very much for the question. So for us at Nist, as you know, we work in standards as a voluntary consensus-based system. And so we really look for forums to where we can gather industry and other stakeholders in order to develop the standards that are needed. So Nist is currently very active in the international standards arena, really trying to provide technical expertise and focused on the technical standards that will enable transparency and consistency across all the measurements that are needed to track emissions and sinks. Currently, we are working on in the technical groups and the International Organization of Standardization, ISO, and also within the American National Standards Institute, ANSI, and with the subcommittee that is focused on these greenhouse gases and related activities. It's very active and a lot of progress is being made.
That's exciting to hear. Are you going to get consensus? I mean, this is a global thing. I mean, do you see some consensus happening in the next 2 years?
On the technical front, I think we are making progress, and since it's a technical foundation and focus for the areas of work we're concentrating currently, then it's, yes, I believe that's certainly.
Oh, that's great to hear. Dr. Hubbell, a study conducted by Argonne National Laboratories revealed that the use of corn ethanol reduces greenhouse gases. Very important to me, my #1 in the country in ethanol production. From 2005 to 2019, corn ethanol production nearly quadrupled in the United States. During that same time, scientists found a 23% reduction in ethanol's greenhouse gas emission intensity. EPA's greenhouse gas reporting program collects greenhouse gas emission data from individual facilities and suppliers of certain fuels and gases. So the question is this, it sort of begs the question, is corn ethanol one of those things that can help us, and at what level of engagement can we see from this sector? I mean, is this something that we should promote and that's positive?
So I can only really speak to the research that we're doing, which has been focused on the oil and gas industry and on landfills. I think that this question of emissions from ethanol is a very important one. And we have folks within our Office of Air and Radiation who can probably speak better to the question of how that feeds into greenhouse gas inventories and the role that they play. So if I'm happy to take that back to our colleagues in Office of Air and Radiation.
To me, it's really interesting. And for me, it's about the regulatory environment with the EPA and when it comes to agriculture and ethanol and where that's going. With that, I've got another question for Dr. Lynn. You know, our farmers in Iowa, we can all say that carbon in the soil is a great thing, because it can increase crop yields. That's a fact. And in fact, land absorbs approximately 26% of the total emissions humans put into the atmosphere each year. So this is really big. But when it comes to specifics, exactly where sinkholes are located, how they work, and how long they will continue to absorb carbon dioxide, there's a lot of uncertainty. So my question is, how do we increase the knowledge related to greenhouse gas sinks and their single area of research, and whether there's what type of data collection and modeling and verification can we do that can be beneficial? Again, I come from an agricultural state, and this is sort of a big deal.
Certainly those are worthy of research, as we've heard from my colleagues, and we work in partnership for that. And basically in the scientific enterprise is really focusing attention and resources to do the best possible way to both understand and to quantify the effects that you named. So I think it really takes a whole system approach of many different types of measurements and modeling, especially modeling approaches, to really get at the detailed answer that we need to be able to answer that question.
Yeah. So my time is running out, but Dr. Lin, would you agree that farming, agriculture, promotes the reduction of carbon in the atmosphere?
This is not my area of expertise, but I would say that there is certainly that can be monitored and measured and quantified.
Okay. Thank you. Thank you for that. And I yield back. Thank you very much.
Great, and with that, we're going to hear from Mr. Tonko for 5 minutes of questioning.
Thank you, Madam Chair, and I thank you and Chair Cheryl and Ranking Members Feenstra and Bice for holding today's hearing, and to the witnesses for being here today. The concentration of greenhouse gases in our atmosphere due to human activities hits record levels every year. Without major cuts to emissions, the driving force of the climate crisis, humanity and our environment will continue to endure the consequences of an increasingly warming planet. The work that all of you are doing at your respective agencies is indeed critical to ensuring that we have the scientific and technical data. These data are then utilized to improve our understanding of greenhouse gas emissions, their sources, and indeed their solutions. I believe our first priority in climate action is to mitigate our emissions in every possible way. So, Dr. Hubbell, how does ORD's research on greenhouse gas emissions measurement support innovation?
So we work very closely with industry partners as well as with other agencies and with states to be able to identify the best new technologies that can help us to be able to characterize emissions, especially from leaks that are coming from oil and gas operations and in landfills. And we do this in a number of ways. We have cooperative research and development agreements that we enter into with industrial partners. We've worked with close to 20 industrial partners over the last number of years to be able to develop and test these technologies. And these cooperative research and development agreements allow us to more easily share data and expertise, including proprietary information, so that we can get the best technologies developed. We also have our small business innovation research program that allows us to fund developers of innovative instruments to be able to address the emissions from these important sources. And we also have a prize challenge program that we work on with other agencies to encourage innovation by putting out a problem and then asking for creative solutions that we then are able to promote and support. So we have a number of different ways we work on innovation, but it's always in a partnership, and that's a really key part of the work we're doing on emissions measurement.
Thank you. I appreciate that. And you state in your testimony that you have helped improve greenhouse gas inventories. Can you share some examples, please?
Sure. So one of the other areas that we work on, in addition to landfills and oil and gas, is we identified there was an opportunity to better characterize the emissions coming from reservoirs as well as other freshwater bodies like lakes and rivers. And there was a recognition that these water bodies can be a significant source of CO2, methane, and nitrous oxide, and that it would be very valuable to be able to characterize these sources so that we got a better overall picture of the national greenhouse gas inventory. So our scientists have worked with others in the federal government, including USGS, to be able to characterize these emissions, especially for methane. That information has already been included in national and international greenhouse gas inventories. It's been recognized by the IPCC and is useful to other nations as well as the US. In addition, the work has got some very specific benefits to operators of these managed aquatic systems as they're looking for ways to address multiple objectives like managing water flows as well as trying to reduce emissions. So this has been very important research that we've conducted recently.
Thank you. And would you cite additional opportunities within your agency for collaborations with the private sector, with research institutions, and other stakeholders to address both community level and broader measurement concerns?
Yes, we are always looking for opportunities for additional collaborations with industry partners. We do also have a Science to Achieve Results grant program that provides funding to academic institutions. And in fact, we are, as I mentioned in my testimony, we are issuing a request for applications this year, hopefully to be able to address landfill emissions. We hope to be able to fund about $1 million in grants to help address this important sector.
Right. Are there any other members on the panel wishing to comment on that given set of opportunities that you see for your agency? Mr. Dr. Stein?
In terms of interacting with the private sector?
Private sector or institutions for research?
Yeah, in terms of the private sector, as I mentioned in my testimony, we are closely working with the airline industry to include measurements of greenhouse gases in their airplanes and basically to detect changes in the vertical, which is key to link the satellite images with concentrations, so we can utilize that in a unified system that can provide information to the stakeholders.
Thank you. Anyone?
And I'll just add that that we are working with the private sector to transition our technologies, our observation technologies, to them so that they can play a role and we can move on to the next more difficult science questions, as well as interacting with industries like agriculture, so that they can understand both how their crops are serving as sources and sinks of greenhouse gases, but also how their crops may be impacted by the climate change and how that may drive changes in how they interact in the carbon cycle.
Wonderful. Thank you. Well, I've used up my time and more, and so I appreciate the patience of the chair. And with that, Madam Chair, I yield back.
All good stuff. And if there are members who wish to submit additional opening statements, your statements will be added to the record, either at this point or from the time when we concluded opening statements. I'd also right now like to recognize Dr. Baird for 5 minutes of questioning. Thank you.
Well, thank you, Ranking Member Stevens and or Feenstra and Madam Chair Stevens. I appreciate you coordinating this committee, and I always appreciate the witnesses sharing their expertise about these subject matters. And so with that, Dr. Hubbell, I'm interested that, and from the fact that in my district, Purdue University has the Climate Change Research Center, which is focused on the interdisciplinary aspects of climate change. So how, my question is, so how does each agency translate monitoring and the numbers to people on the ground? For example, agricultural communities seem particularly capable of immediate actions that slow climate change and enable them to benefit economically. So how is greenhouse gas data like that coming from NASA and Noaa satellites being translated to the actionable farming community and farming practices?
So I'll certainly let my colleagues in NASA and Noaa speak to translating their satellite and other information. We do work to try to provide information in usable formats for different types of decisions. One of the things that we've been working on in ORD is trying to, for example, develop more opportunities for community engaged research where we work with the communities directly to understand measurements and be able to interpret them for supporting their decisions. And we are hoping that the work we're doing to reduce the cost and increase the ease of use of different measurement technologies will allow communities like the ones in your state to be able to better understand the measurements they're seeing and use that information to support their decision making. So we are working to try to not just reduce the cost and improve the accuracy of measurement technologies, but also to make them easier to use and for us to make it easier to share information that's collected by those technologies.
Along in that same vein, it just occurred to me about, we're collecting a lot of data on the farms with our machinery and our equipment. Do you have access to that kind of information, or do you get feedback from the agricultural community and the monitoring that they do?
So as I mentioned earlier, we're not doing any current research with the agricultural community looking at measurements with the ground-based measurements. Certainly, EPA has worked with USDA and others to be able to think about ways we can address emissions from the agriculture sector. But right now, we're not doing any current research in that area.
Thank you. Dr. Lynn, do you have any additional concerns that you might share with us regarding this question?
I think we have models of which we are testing with the urban dome test bed is an approach that is looking at how to integrate multiple sources of information into a whole, so we can get holistically a lot more accurate picture of that. That's idea certainly could be extended into rural areas and as a conceptual idea, and so I think any information certainly is useful to obtain.
And Dr. St. Germain, I think that earlier they referenced NASA in regard to Dr. Baird's question, so perhaps you want to comment there?
Yes, absolutely. We have a lot of work going on with the agriculture sector in terms of exchange of information and understanding. And there are three, I'll say, principal mechanisms by which that happens. One is through other agencies like USDA or Department of Interior, where we integrate our information into data products and tools that are already accessible to these communities, so they don't have to learn another one. In cases where we can make tools, information, insight available to them, where such a tool doesn't exist through another agency, we do direct applications. We build applications, generally making them openly available, web-based, and that sort of thing. And the third, and this is a recent thrust area, is working directly with the agriculture sector. That is everything from the farmers themselves to agribusiness, to actually learn more about what data they have on the ground that may be useful to us to improve our models and capabilities, and likewise, how they need information delivered to them. And I just spent a week this summer, or earlier this spring, at the Commodity Classic meeting with the major commodities groups to really figure out how to tighten up that coupling. Thanks.
Great. We really appreciate you doing that. So Dr. Stein, we only got about 30 seconds.
Yeah, I can give you a couple of examples of what Noaa is doing in terms of actionable data for agriculture. We run the National Integrated Drought System, and in climate.gov you can have that information readily available. And also we have our geostationary operation environmental satellite series that are providing operational and long-term measurements of changes in land use that can be very useful for the agriculture sector.
Thank you very much, and I yield back.
Gentleman yields back. The chair now recognizes the gentleman from Pennsylvania, Representative Connor Lamb. You're recognized for 5 minutes, please.
Thank you, Mr. Chair. My first question is for Dr. Lynn. Dr. Lynn, in Western Pennsylvania, there's a fair amount of natural gas drilling taking place and has been for a long time. And what you hear from some of these companies is that they are basically being rewarded by their own investors and stakeholders for continuing to try to reduce methane emissions below 1% if possible. And that is also their strongest argument for being a progressive alternative to coal in terms of our progress toward climate change. But both of those claims rest on accurate measurement of what their methane emissions actually are all throughout their system. And so my question for you is about your level of confidence in what drilling operators are using to sense and detect and report their own methane emissions, as far as the reliability of the equipment, the accuracy, whether they're measuring everywhere that they should be measured, whether the standards for this equipment are what they need to be, or sort of how far we have to go in terms of making sure that the measurement being used on site from the wellhead all the way to the end user is as accurate as it should be.
Thank you very much for the question. Certainly, those are very important questions for the reasons that you stated, and also for us as a measurement institute for the interest of making sure the data is consistent, transparent, and accurate. At this point, as I understand it, is that the industry is using a range of technologies to do these measurements and reporting them, and new technologies are being developed every day. So I think this is an area where a standards level activity, where it's voluntary consensus based on the best technical solutions, would be appropriate. I'm not exactly sure how that is related to the specific industry at this point, but that is an area where we could look into.
If I might.
I'm checking with folks right now, and I'll check in the room as well.
Oh, looks like he's back. If you could just unmute the hearing room, looks like Dr. Lin is back.
Oh, I'm sorry. So my answer was that there's a range of technologies used by the industry, and that would recommend that.
You're still muted, Dr. Lin, so just hold on a second.
Okay.
Yeah, they probably don't hear. I'll let them know.
Okay.
So we can hear you. We can hear Dr. Lin in the room, but you can't hear him, Congressman Lamb? Oh. Just in a temporary hold. Okay, we'll take a 5-minute recess.
Can someone try something? Can the room hear us now?
Test.
It looks like we have audio back in the room. We're just waiting for the video to return.
Hearing room audio, test, test. Larry, I can hear you.
Yep, and I can hear you.
Is it? Testing 1, 2, 3. Audio in the hearing room. Test.
Yeah, I'm hearing you. Can you hear me?
I can hear you, Larry.
Okay, great. We've got audio. We just got to get the video back in room. Thank you.
Okay.
Mr. LaTurner, can you hear us? Okay, what about Dr. Hubbell?
Ms. LaTurner is not.
Okay, but Dr. Hubbell can hear us.
Yes, I can hear you.
Okay, well, so okay, well,
Yes, we've got audio back, ma'am. We're just waiting for the recording studio to return the video picture back, and then we can start back up.
Okay, thanks. We're gonna get the video started and we'll get started, thanks.
Yep, and there's the video, so we can start back up. We were still with Mr. Lamb.
Congressman Lamb, we're going to recognize you for another several minutes of questioning. Thank you.
All right, yeah, we don't need too much more. I'm going to restate it because we didn't get a whole lot of Dr. Lynn's answer. But my basic question is that it's increasingly important that drillers and natural gas distributors and everyone who's responsible for that whole kind of ecosystem are able to report accurate results as to their methane emissions. It's very important for their own investors. Obviously, it's important for any future scheme in which we are trying to either pay for or tax, carbon emissions or savings. So my question is really a technical one about your level of confidence in the quality of the sensors and equipment that they're using right now, and whether new standards and rules are needed in order to make sure that what they're using actually provides us with accurate information.
So for our point of view at Nist as a measurement institute, this type of, the problem you described is a very real one. And we would go more towards the voluntary standards arena for where the stakeholders within the problem space you described could get together to really tackle exactly what are the standards measurements for the technologies and how to report them. Since there's a range of technologies, each one has its strengths and weaknesses. I'm not really in a position to comment on any of those. Perhaps my colleagues who also have equities in this space could have more to add.
Yeah, I thought Dr. Hubbell potentially, I believe it's the EPA that has actually published some of the data showing the way that methane emissions are underreported and have been for some time. So I don't know if you had anything to add to that as far as just kind of weighing in on the quality of the equipment that we're talking about. Sometimes we talk about just, are they monitoring it at all? Are they monitoring it in the right places? But even, I guess my question is, even in where they are monitoring methane emissions, are we using equipment and sensors to do so that are up to the proper standard?
So just as Dr. Lynn said, I think it depends on the technologies, and and there is a wider range of those technologies that are used. And again, we're focused right now on trying to improve the technologies for leak detection and repairs so that we can quickly identify these sources of methane and stop them. So that's really our focus right now, is on developing better ways to do that. And also, it's not just the accuracy of the measurements, but it's also making them at a low enough cost that they can be used,
Right.
and also trying to make them easier to use. Some of these very accurate measurements are more costly and more difficult to operate. So it's really important to think about all those.
Well, I guess what I'm getting at is I don't believe that we have any real requirements in place to sort of force operators to choose the highest quality equipment or whatever the cutting edge of what you're just discovering, right? To Dr. Lynn's point, we're still in a very voluntary world when it comes to choosing, the best equipment to use.
Yeah, again, I think it's important to work with our industry partners to understand what the needs are in the particular industries and in different parts of the country as well.
Great. Well, thank you very much for your participation and for all your hard work. And Madam Chair, I yield back.
Thank you. And now we're going to recognize the Congresswoman from North Carolina for 5 minutes of questioning, Ms. Ross.
Thank you, Madam Chair, and thank you so much for your leadership on this important topic, and thanks to the ranking member and all of our witnesses for joining us. Before being elected to Congress, I was a renewable energy lawyer in North Carolina and worked with companies there to mitigate and repurpose captured greenhouse gases. Some of the first methane and also biogas projects I got to work on. And in my state of North Carolina, we're home to a unique kind of carbon sink ecosystem called Pocassin, which is naturally occurring wetland. In fact, in the 1960s, North Carolina was home to over 2 million acres of Pocassin ecosystems, nearly 75% of the country's total. And the measurement of carbon emissions of these ecosystems is vital to land management that keeps carbon locked in the soil rather than in the atmosphere. My first question is for Dr. Lynn. In your testimony, you discussed how vegetation and wetlands in cities complicates measurements of urban methane and carbon dioxide emissions and make it difficult to identify their sources. Can you talk about why the presence of vegetation and wetlands in cities complicate these measurements, and what is needed to improve the accuracy and attribution of urban and regional methane and carbon dioxide emissions to specific sources?
Thank you very much for the question. It's certainly a complicated system to look at. Basically, vegetation and wetlands near cities complicates measurements because they are fluctuating, and they're fluctuating at levels that would impact the accuracy of the overall measurements of what the greenhouse gases emissions and sinks are. And so what we need is a much better idea of studying about the modeling about how vegetation and wetlands and their fluctuations have an impact on greenhouse gases. And we'd also need to advance ways, which we have been doing, of how to detect greenhouse gases that are coming from organic and vegetation sources as opposed to human and more urban sources. So there's a lot of work to do there, and certainly we're doing that with our partners here across the government, which have very extensive efforts in attacking the details of how to understand that.
And picking up on Congressman Lamb's last point, how can the private sector be involved and be helpful in these efforts, if at all?
Well, certainly the private sector is very much engaged for many of the drivers that have been shared earlier. So at Nist, our approach is to really build consensus and to convene parties to try to address them collectively. So our Urban Dome testbed program is an example where industry and multiple stakeholders come together, share information, and contribute to the overall quality of the measurement of the overall system, in this case, an urban testbed.
Okay, thank you. And then I wanted to take a little bit of a broader view because, as you've all indicated, we're not just measuring greenhouse gas emissions from the United States, but from all over the world. And to anyone who wants to use this next minute and 30 seconds, why do we need global measurements of greenhouse gas emissions if the primary focus of Congress is on the United States? And I'll open it up to whoever is interested in answering.
Yes, Congressman Ross, thank you for the question. It's the Earth, as I mentioned earlier, the Earth operates as a system. And so emissions in one location, of course, don't stay put. They mix in the atmosphere, they affect the entire carbon cycle. Likewise, regions around the world absorb carbon dioxide in different measures. And that's really where the power of merging surface-based observations with space-based observations can be most impactful. It's the satellite observations that can give us those insights in regions of the world where we don't have the surface-based observations, because they too are impacting the global system.
Does anyone have anything to add with the?
Yeah, in terms of we need a global view, because everything, as Dr. Germain presented, it's intermingled. And we also not only want to detect changes in the US, but we also want to detect changes in other countries and see if other countries are really and holding them responsible for their commitments. So that is really an important thing. And let me just give you an example, going back to your question about wetlands. The work that we are doing at Noaa in terms of detecting changes in natural environments, like in wetlands, we can use isotopes of carbon to distinguish between natural and anthropogenic sources there. And we were able to distinguish, for instance, that the latest increase in methane that we have been observing in the last 10 years globally is due to changes in biological activity in wetlands.
Thank you very much for your indulgence, Madam Chair, and I yield back.
Indulge away. With that, we're going to hear from Ms. Stansbury from the beautiful state of New Mexico for 5 minutes of questioning.
Well, thank you, Madam Chairwoman, and also to the ranking member, and thank you to all of our esteemed panelists for being here today. I know we've been talking a lot this morning about the science specifically and how we address the issues around monitoring, around standardization of how we measure greenhouse gases, and then what do we do with that information to help inform our climate action. And I want to kind of direct the panel towards the policy side of the equation now, and specifically science policy. You know, we all know we're at a global tipping point. We know that we have to take action as quickly as possible. And part of being able to take effective action on climate change requires that we know that the methods and the tactics that we're using to tackle emissions and sinks is actually effective, and that we are making the investments that have the biggest bang for the buck. And so I know we've already touched on some of this morning, but I want to ask each of the panelists, since you sit in different agencies and work on these with your other agency partners, are there specific policy actions that you feel Congress or the federal government as a whole could take that would help to standardize the way that we do measurement, the way that we deploy instrumentation across the U.S. on measuring carbon emissions and sinks as a sort of network of monitoring, and as I said, standardizing the ways that we do it, and then how we deploy that information in terms of determining where to make investments as the federal government in both emissions reduction and in sinks. So if we could, why don't we go ahead and start with the panelists from NASA and go down the line.
Yes, so I think NASA's contribution in this space is really to provide the global, transparent, repeatable, open, trusted science on which policy decisions can be made, and that is reliant upon the sustained support and open process for calibrating our surface observations and as well as our airborne and spaceborne. So I think the sustained focus on having that open those open sources of data is really going to be foundational to informing the policy choices that that members of this committee and others have before them, and assessing the efficacy of those as we move along in time.
Thank you. And let's go to Dr. Lin next. You know, are there things that we can do as a federal government, like I said, either as Congress or in the administrative branch, that would help to standardize the way that we're doing emissions tracking, and that would help to bring more coherence to all of the science that you all are talking about today?
I think the progress in the Interagency Working Group has really been really outstanding, and that is the forum in which these questions you're asking are being addressed. And so I think it's really it's a continued sustained, as my colleague stated, a sustained support of encouraging and facilitating that exercise. It's very difficult to pull all these multiple measurements and different points of view into a coherent whole that's precise, transparent, and we can have confidence in it. But a tremendous amount of progress has been made, and certainly there's more room to go.
Thank you. And Dr. Stein?
Yeah, we're making, I'm part of the Interagency Working Group, and we are making strides to tackle this problem from day one, and we see this as a big challenge in terms of harmonizing and sharing data assets. Also, the World Meteorological Organization is tackling this problem at this right moment. So you're asking the right question, and we are trying to provide an answer as soon as we can. So we're working on that.
Thank you. And Dr. Hubbell?
Yeah, I just wanted to start by saying that, you know, the current inventory that we have is very high quality. And really what we're trying to do is being able to identify those few areas where there's an opportunity for improvements that can help us inform mitigation actions. But what we have now is very high quality. I think in terms of the interagency effort, I think as the other panelists have said, the Interagency Working Group has been really a great place to be able to work on these challenges. And one thing I did want to add to that is that it's important, as we're getting new research and getting these systems linked, to be thinking about having a steady flow of high quality data so that we can track trends and not just a snapshot in time. So being able to do this over time is really important.
Thank you. And I know I'm out of time, Madam Chairwoman, but I just want to add that myself and other colleagues are very interested in looking at opportunities for Congress to partner with the administration to help bring a policy framework to coherence in how we measure and deploy different climate strategies. Obviously, this is the most important and pressing question of the day, is how do we meet our goal of reducing our carbon emissions by 2035, 2040, so that we don't cross this catastrophic tipping point. And so I look forward to working with all of you on that, as well as climate resilience and climate justice, and really thank all of you who are working in our federal agencies for your service in this area. You are doing some of the most important work on the planet, and we thank you for your service.
The gentlewoman yields back. The chair now recognizes the gentleman from Illinois. Dr. Foster, you're recognized for 5 minutes, please.
Thank you, Mr. Chair, and I'd also like to thank Chairwoman Stevens, Ranking Member Feenstra, Chairwoman Sherrill, Ranking Member Bice, and our witnesses for joining us here today. Much of the testimony today has emphasized how this area of research is really reliant on a number of stakeholders, both throughout the federal government as well as other sectors. Drs. Stein and Hubbell, in both of your testimonies, you mentioned several partnerships that your departments are involved in. Could you expand on what partnerships your departments have with the Department of Energy and our national labs, and the impact that these partnerships have on monitoring, measurement, and verification of sources and sinks of greenhouse gases?
Thank you for the question. We have a long-term partnership with the Department of Energy, mostly working on modeling of climate variables. We also have worked with and continue working with the Department of Energy in terms of developing measurement techniques, mostly for boundary layer, the lower part of the atmosphere measurements, mostly in terms of meteorological variables. There is a very long-term relationship between the Department of Energy and Noaa, in particular, in that area.
Thank you.
And I'll just add that, our work right now on the oil and gas sector, we do have some collaborations and coordination going on with DOE, as well as with our other federal partners, to be able to better understand how we can characterize emissions from this sector. And we've also worked with DOE and other agencies in addressing the overall inventory for almost 30 years. So it's been a long-term partnership, and it's something that we expect to continue going forward.
Thank you. And Dr. Lin, your testimony highlights how Nist has initiated a documentary standards effort aimed at advancing the implementation of mature measurements-based scientific tools and methods. This aims to lead the development of global standards as well. And so how does Nist incorporate the best practices of the research community into their standards development?
Thank you for the question. Our research and our attention to the research environment directly informs our work in the standards forums. So in these forums, those are voluntary consensus areas which are focused on the technical solutions and standardization. And we bring all the knowledge and the input from the research space that we know into that arena, so that the best technical solutions can be determined.
Okay, and could you speak a little bit about the importance of developing these global standards as we continue to understand the global impact of greenhouse gas?
Well, I think, as my colleagues have very well stated, is that the global system is one as a whole. There's no boundaries for gases as they traverse the globe. And so as we are monitoring our own emissions and sinks, that we need to have a consistent way of how to know where the greenhouse gases and other things we're monitoring are, and to put it on the same baseline is a critical step in that.
And how important is the impact of the loss of contact with Russian scientists going to be in this field? You know, I know from my experience in physics that the Russians are some of the most brilliant and well-trained scientists on Earth. And they've also been very involved in things like understanding what Siberia is going to do to greenhouse gas emissions. And some, in light of the current situation in Ukraine, some Russian scientists are heroically standing up, others not so much. But we're going to lose contact with a lot of them. And how big a hit is that going to be in our ability to deal as a planet with greenhouse gases?
For our point of view, so I'm not sure, I don't know directly on this particular field of the impact of what you noted, but in general, we've concentrated on multilateral fora, which it's a multilateral engagement, and so it's not really dependent upon one country or another. And even in that environment, in the technical arena where we work on, largely that is still in place because we're looking at technical solutions.
Yeah. Anyone else want to comment on that?
Likewise, when our interactions with Russian scientists have generally been through multilateral fora, we haven't historically had access to Russian space-based data, so we aren't seeing a loss there, and we're continuing to use the data from U.S. systems as well as other international partners to understand all regions of the globe, including Russia.
And I think, Russia as a country has not always been interested in having the numbers well known as they apply to Russia, but it's, it's going to be, my guess it's going to be very important because this is a whole of planet effort. Anyway, I am now out of time and yield back.
The gentleman from Illinois yields back, and I believe that concludes the list of colleagues who choose to question our panelists. Before, however, we bring the hearing to a close, I thank our witnesses for testifying before the committee today, and I offer those thanks certainly on behalf of the chairs and rankers who hosted this committee hearing. The record will remain open for 2 weeks for additional statements from the members and for any additional questions the committee may ask of the witnesses. I ask if you would please respond in a prompt fashion. And with that, the witnesses are excused, and the hearing is now adjourned.